This is John from Robison Service in Springfield, Massachusetts. We're going to show how to deal with a blown head gasket and how to get cylinder heads off of one of the 6.75 liter Rolls-Royce or Bentley V8 engines from the 80s and 90s. We're looking here at a CIS injected engine, which is what was used from the 1980s through the 1993 model year. 1994 went to Bosch and then Zytek electronic injection. The first step to do this job is to take the hood off. Now the hood is held on by 8 bolts right here, and what we do is take a yellow temporary marking pencil and we mark here a line where the hinge meets the hood. Mark a line here. We go to the other side and we mark a line there. Then we go in here and we unscrew the ground wire, because that's tying the hood to the body. We go over here and we follow the hood light wires down to where they will connect in between the coolant tank and the hood spring, and we disconnect those. Once that's done, we have 2 people hold the bonnet from each side, and it's only about 50 pounds because it's aluminum, and we carefully take these bolts out and then lift the hood clear and set it down. Now we start disassembly to get the heads off. So here, that Rolls-Royce logo is on the valve cover, which is on top of the cylinder head. So we got quite a ways to go to get these off. First, I would take the AC compressor loose, take the air pump loose. We usually put a heavy pad on the fender to protect it, and we can flip the AC compressor over, or if the system's not charged, we can unbolt the pipes there and just take the compressor right off the car. The fuel lines we'll disconnect here, as you can see, and then the pipes to the fuel injectors on a CIS car have to be very carefully unbolted. These lines are quite rigid and the fittings are steel. The fuel distributor is aluminum, so if you cross thread them and jam them, you're going to have a big problem, and you've got to use extreme care to get these unthreaded and then threaded back in. Take all those loose, and here we can look down at an injector. They get unscrewed at the injectors. Take the lines off, then this Rolls-Royce top can come off, and you can proceed to unbolt the fuel distributor assembly and lift it off. One of the big challenges taking cylinder heads off these motors in the car is getting the exhaust manifolds loose. So we can zoom down and we can see the exhaust manifold straight down below us, and you can see above it there's an exhaust, there's an air injection tube for the emission control on this particular car there. But that's the manifold down below the spark plugs. And you can just see right in the center of the frame one of the upper bolts that holds the manifold on, and there, now centered in the frame, is the rear one. And there's a metal strip in between them that is bent up to keep the bolts from unwinding. So you've got one set there, and you got another set here, and yeah, you can see them. You can't even see the lower bolts. Those have to be reached by feel from under the car, and you have to get them off to take the heads loose. We're going to go to an engine that is not in the car to see how this is done. This is a bare Rolls-Royce cylinder head So you can see here are the rows of head bolts. This bolt is exposed, that's exposed, and then you have here and here. These are your push rod tubes. These bolts also carry the rocker shafts. These are the valve guides. In an assembled head, the valves will be protruding here. We turn this over. We can see the combustion chambers. And what happens in these motors when you have a cylinder head gasket blow out, the gasket has a fire ring, a steel ring that encloses the periphery of the combustion chamber here. So the main gasket is made out of a fiber material, and this steel ring protects the fiber material, and it's all held tightly by the compression from all of the head bolts. Over time, the fiber will break down, and as it breaks down, that reduces the clamping pressure. And the other thing that'll happen is getting the car hot will stretch the bolts, and that will gradually lower clamping pressure. So those things combine, and at some point, the combustion pressure starts to push through the fire ring. The fire ring will often break down and crack. You'll get combustion gas flowing through, and these here are your coolant channels for water to cool the cylinder head. So it'll push through into here, and it'll start to pressurize the cooling system with little bubbles of combustion gas. The bubbles obviously displace the coolant, and when that happens, the coolant doesn't cool the engine, and you start to get localized overheating, and that's why engines overheat when the head gaskets are starting to fail. Now, we just looked at the cylinder head, and here's a cylinder head installed on the engine, and here on the other side of the engine, the cylinder head has been removed. When you go to remove or reinstall the heads, it's important that you take the bolts loose and you tighten them in order. So, for example, if you loosen here, then go here, 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 here. You need to go diagonally across the engine so that you don't subject the head and the block to uneven stresses. Now, it used to be common when a head gasket was changed to bolt the engine together, run it a few hundred miles, and recheck the head torque. Well, you can't do that on these engines because the upper rows of head bolts can't be accessed without extensive disassembly. So what we do in this shop is we bolt the head on, we torque it, we let it sit through a weekend, and then we'll come back on Monday and we'll recheck the torque. And if there's any give in one of the bolts, that means that stud's attachment is weak, and you have to pull the head back off. You'll have to remove that stud and install an insert. So let me just show you what that involves. These upper bolts here, the upper bolts are threaded directly into the block. So if this bolt were pulling loose, we could take this out, we could drill this. And this is a really critical operation. We have a jig that sits flat on the head and aligns the drill bit so that we drill perfectly straight down that hole. If you drill this crooked, you won't be able to put the head on. So really, really important. We drill in here and we enlarge the hole, and then we will thread an insert into the hole, and that's seated with Loctite, and then the stud goes into the insert. Now, when we do that, the larger insert gives almost twice the gripping area of the original stud, so the repair is actually much stronger than the original. And if we were building one of these engines to go racing, we would actually take all of these studs out of it. and we'd put inserts in there to ensure that none of the studs blew under the stress of running. Where this gets complicated is if we look at these middle studs, you see how there's passages because oil and coolant come up these holes. And you see how that stud is loose in the hole? Well, this stud is seated quite deeply in the block. So taking this out, drilling it, and putting an insert in is much more difficult. It takes a lot more precision drilling skill, but it can be done. Replacing those central studs can easily turn into some thousands of dollars in machine work. So you want to be really careful with these studs, not damage them. And if you do, well, that's what you're going to have to do to replace them. Another thing that we'll look at here while this is it's open, you can see that on the cylinder head, we had a couple of large openings in the head, but we just have small round openings in the engine block, and that creates kind of a pattern on the head gasket, and it sets up, I think, some turbulence there, and that may be a factor in the failure of these gaskets, but it's how they're made. If we look from the edge, you can just barely see that the stud, that the cylinder liner is standing up. See the glitter where my light reflects off it? The liner is standing up just a little bit above the level of the block. And you have to have that to ensure that when you put the head gasket on, the head gasket's fire ring sits on top of that liner, and then the force of the head bolts compresses it very tightly, and having the liner protrude a little bit above the block ensures that that is the most tightly clamped part of the system. And that, of course, is most essential because when the fire ring blows through, your head gasket is gone in an instant. And just as an aside, we're looking at what you might think is rust in here, and it's not rust, it's cosmoline on this engine, which is a reference engine in storage.
A little bit.
So
when you say they're protruding.
When the liners are set into the engine, they are only installed to protrude 2 to 5 thousandths of an inch, depending on what engine we're assembling. And usually, when you take a head off, if you were to measure the liner protrusion, you would measure a larger amount of protrusion than that, and there would be some unevenness. And people often think that that means all the liners have the wrong protrusions, or there's corrosion under them, or there's some big problem, and it's actually not the case. The liners are sealed against the engine block by rubber O-rings, and when the liners are originally pushed into place, they are compressing the lower O-rings, so there is always some force from the rubber pushing back up. So once the liners have been seated and they've been put down on a press and set to the right thickness to give the correct protrusion, once we take the pressing fixture off, the liner will rise 3 to 6 thousandths of an inch typically. So we'll often set a protrusion at 2 thousandths, and then when we take the fixture away, the liner is standing up 6 or 8. And that's not an error, that's just the rebound from the rubber. And when the heads are bolted down, the liner will be in the correct place. So don't be misled by that. If you want to check liner protrusion, you need a jig to hold the liner in place with the correct clamping force. So here's the engine bay with the cylinder heads both finally removed. You might notice that this is actually not the same engine bay. We started with a CIS engine, an early 90s Corniche. This is a late 90s Motronic Bentley Turbo R engine, but the block and the core here is exactly the same. So this is what you're going to see when it comes off, and I'm going to show you a couple important things to look for. How do you know if there is damage to the pistons? Well, the only way to absolutely know for sure is take the engine out of the car and take it completely apart. But you can get a really good idea looking down here. This is what an undamaged cylinder wall is going to look like. There are no vertical up and down scoring marks. There is also, we are looking right now at the cylinder where the head gasket failed. And what we're seeing here is that there is no visible damage to the liner, no visible damage to the block. There's no scoring. I want to show you an important way to tell a blown head gasket, because you can do this with a fiber optic camera. Look at the top of that piston. See how it's all carboned? Look at the next one, all carbon. Look at the next one, again, all carbon. Now, look at the front one. See that? It's all scoured clean. There's almost no carbon left on it. That scouring is the result of the steam cleaning action of engine coolant getting into the cylinder through the failing head gasket. And then when the engine fires, that's flashed into high pressure steam, and that steam, just in a matter of a few minutes running, has done the scouring that you see. So this is an absolute certain indication of a head gasket failure on that cylinder. And next we're going to look at the gasket, and we'll see how we can match the evidence of the gasket to the evidence of the piston top. This is an old but not yet failed head gasket. Okay, the signs of that. See the red area in the head gasket is to seal a boundary between an oiled area, a coolant area, or the combustion area. None of these red boundaries are broken. There's no evidence of the gasket breaking down really badly, but it's starting to go here, see? Yeah, so we're starting to get some failure there. The fire rings are starting to show some deterioration, but they are not failed. So this is an original head gasket that's got a little bit of life left, but certainly you never reuse head gaskets, and this is a job that is timely. This would not last much longer. No. We're going to look at its sister now. Here's the other side, and this is the one that failed. So we looked at the piston and how it was scoured. Here's how the scouring happened. Here you can see that I'm going to just, here's where the fire ring fractured. The fire ring deteriorated, and I can actually almost flex this. See how it's started to break? So the fire ring has failed. That allowed high pressure combustion gas to come in here, and we saw a moment ago, looking at the cylinder head, there were two openings here in the head for coolant, and this is the return into the block. So that allowed high pressure combustion gas here into the coolant stream, went back into the block, and it circulated through the engine, and the bubbles impaired the cooling, and the engine immediately started to overheat. So this is a sudden failure, and the engine was in its, really last moments of being drivable by the time we took it apart. That is a failed head gasket. And that's what you should expect to see if you're looking for a failed head gasket. So here we are looking at the pile of parts that come off in order to take the heads off a Turbo R motor. The older CIS motor would be very similar, except it'll have the fuel distributor instead of these intake pipes here. You can see from the number of parts, and you see how we keep track of, like these are the head bolts, we keep those separated, we keep our gaskets separated, we bag up the exhaust the exhaust nuts and bolts from side to side, mark them. We bag the various spacers. This is not a job where you just take the pieces and throw them all casually into a solvent tank, and it's not a job for the faint of heart. Be sure that you're ready for what you're getting into if you start taking apart your Rolls-Royce or Bentley V8. To start the job, we will normally take a hose off the bottom of the engine and drain the coolant. Some of the Rolls-Royce and Bentley radiators do have drains on the bottom, and if yours moves freely, by all means use it, but we are always wary of the risk of loosening a drain and having it snap off, and then we have to replace a radiator, or even worse, we have to get into an engine block repair. So generally we'll just take a hose loose. Now, in much of the United States, coolant is not legal to just pour down a drain. It's something that we will pour into 55-gallon drums and recycle, and we do not reuse coolant once it has been polluted by combustion gases in a damaged engine. We will always put new coolant in these engines. In the cylinder head job, two things have to be absolutely checked for flatness: the exhaust manifolds and the cylinder heads. Here, Jack will show us checking a manifold.
So this manifold is not totally clean, but you would completely clean the bottom face of it. It would then be dry, it would have no residue on it. You'd
Want to just flip it over and just show what the bottom looks like?
This is, again, not totally clean, but it would normally have discoloration.
That's from the heating of the exhaust gases over the years.
Yeah, but it should feel smooth.
And so what we want to see is that these sealing surfaces are all in a straight line.
In a plane.
In a plane, and they are all flat. And we can do that on this reference table.
So by laying it flat and looking behind it with a light, we can see that there are gaps.
Yeah, there's a gap right there, see?
On this. It may or may not be a problem.
There's a little gap.
But we can see that it's not totally flat.
So
you can
this,
also verify this by trying to rock it with your fingers. And you can feel the play in it.
You can hear it. Now, if we put this on the car and it's not perfectly flat, it's going to put uneven stress on the exhaust manifold gasket. And if the exhaust manifold gasket fails and exhaust starts to leak, now we have a situation where a couple 1,000-degree exhaust gas is jetting out with an aluminum cylinder head on this side and an iron manifold on this side. And the aluminum is going to be the loser in that struggle, so that the hot exhaust gases will quickly cut a trough into the aluminum cylinder head. And so if we didn't machine this manifold flat, we would end up ultimately having to take the cylinder heads off the car again to repair the damage resulting from when the manifold gasket burned through. So this is a really important and oft overlooked thing in head gasket repair. Now, looking at getting the manifold bolts loose, it's easiest to understand that on an engine that's on the bench. This is an older carbureted Silver Cloud era motor, but the manifolds are the same. So here are the upper manifold bolts. Now, in the newer cars, you're going to see a strip of steel between these two that's folded over to keep the screws from loosening. The difficult bolts are the ones on the bottom, and you can see there they are on the bottom of the manifold, and then you've got clamps on the bottom of the manifold. You've got to get under the car and get these off, and then get the manifold separated, get the top bolts off the manifold, get the manifold off the car, and it's going to have to be checked for flatness, and almost invariably when we take these off the car, they need to be milled flat. So that's a really important step. Here's a Rolls-Royce Bentley cylinder head out of service and ready to install. You can see that looking inside, the ports have all been cleaned. They've been media blasted with walnut shells, so there's no carbon, no debris. We press this down, take the keepers off. These are the keepers right here. Wedging the cap here against the valve stem. The springs get tested. We measure how much force it takes to compress them, and on a higher mileage car or a car that's seen higher RPM usage, more often than not we'll replace the springs. Just about every time we replace those turquoise green colored seals. Those are the valve stem seals. You can see there's a little band of spring steel at the top squeezing them against the valve stem. That is what protects you from the puff of oil smoke when starting up an older motor. That's valve stem seal leakage. We will also check the valve guides. The guides are what the valves go up and down in. If those are too loose, we'll replace them. And let's see, we're gonna just turn this over and we'll look at the other side. Here's the other side of the cylinder head. Now first, you see this shiny pattern? That is showing you that this cylinder head has been milled on the CNC to be perfectly flat. You will often hear, especially in car dealerships, of technicians pulling a cylinder head off, slapping a new head gasket in place and bolting it together. And on an older car, a repair like that is always doomed to failure. Because as these engines age, the heat stresses, the hot-cold cycling as it's run, and ultimately the greater stress if a head gasket fails and the engine overheats. The overheating isn't uniform. It'll typically overheat in one cylinder, and that will deform the head. So in all the time I've been doing these Rolls-Royce engines, 30-some years, I have never removed a set of heads for head gasket work and not found them excessively warped and in need of milling. And I would just keep that in mind if you're tempted to just put a head gasket on and be done with it. Here you can see that even though there was obvious evidence of the head gasket failing when we looked at the gasket, now that we have milled this head, this is the area of the failure, and you can see that it's perfectly smooth. You can see that marking, which looks like texture, is no more than a 10,000th of an inch thick. That's just kind of an artifact of the running of the CNC machine, but it's a perfectly smooth surface, no damage to it. We also use a machine to cut the valve seats so that they are at the correct angles and they are all cut exactly the same. The valves are faced on a valve facing machine. Of course, the valves are also either cleaned or replaced. So that's what would constitute a proper valve job on one of these motors before putting it back together. And so we have, and these are always, of course, done in pairs. There's the other head still wrapped in plastic. We'll leave them wrapped up until we're ready to put them back on this motor.